Space is vast, it's bigger than vast, it's an expanse so immense that it defies our comprehension. When we look up at the night sky, we see just a tiny fraction of what exists out there. It's the biggest thing we know. The universe stretches out in all directions, seemingly without end, filled with countless stars, planets, and galaxies. And for the most part, it's remarkably empty. Despite the billions of stars and galaxies, the vast majority of space is just that, space, a void with very little matter. But this emptiness isn't uniform. It's not just a random scattering of stars and galaxies. It's not a smooth, featureless expanse. Instead, the universe has a complex structure with regions of dense matter and vast empty spaces. Instead, the universe is structured like a giant cosmic web. This web is made up of filaments of galaxies and clusters interconnected across the cosmos. Imagine a spider web stretching across unimaginable distances. Each strand of this web is a galaxy, and the intersections are clusters of galaxies. This web is made of galaxies, stars, gas, and dust. These elements are the building blocks of the universe, forming the intricate structure we observe. And in between these cosmic filaments, voids. These voids are vast empty regions that make up a significant portion of the universe. Voids are vast, expansive regions of space that are relatively empty. They are the gaps in the cosmic web, where very little matter exists. They're the holes in the cosmic web. These voids can be hundreds of millions of light years across, making them some of the largest structures in the universe. And they're not just empty spaces. These voids play a crucial role in the dynamics of the universe. They're regions where the expansion of the universe is happening at an accelerated rate. The lack of matter in these voids means there's less gravitational pull, allowing space to expand more rapidly. Think of them as giant cosmic bubbles, constantly growing and pushing outward. These bubbles are not static. They evolve over time, influencing the distribution of matter in the universe. These voids are crucial to understanding the universe's structure and evolution. By studying them, scientists can gain insights into the fundamental forces that shape the cosmos. They're not just empty spaces, they're active players in the grand cosmic dance. The interactions between voids and the surrounding matter help us understand the universe's past, present, and future. These voids are not just empty spaces, they are dynamic regions that provide valuable information about the universe's history and its ongoing evolution. They are windows into the universe's past and future. By examining these voids, we can trace the history of cosmic expansion and predict how the universe will continue to evolve. By studying them, we can learn about the forces that shape the cosmos and the destiny that awaits it. These voids hold the secrets to understanding the grand design of the universe. The universe, as we're coming to understand it, is not a random scattering of stars and galaxies. It's a grand, intricate design, a masterpiece of cosmic architecture that stretches across the vastness of space. Each star, each galaxy, is a thread in this immense tapestry, woven together by the fundamental forces of nature. It's a structured, interconnected web. Much like the neural networks in our brains or the intricate patterns of rivers and roads on Earth, the universe is a complex network of connections. These connections are not random. They follow the laws of physics, creating a cosmic web that binds everything together. Imagine a three-dimensional spider web, stretching out in every direction, forever. This web is not just a metaphor, it's a real structure that scientists have observed and studied. The cosmic web is composed of filaments of dark matter and gas, where galaxies are born and evolve. This is the cosmic web. It's a vast, interconnected network that spans the entire universe. Supercomputer simulations have helped us visualize this web, revealing its intricate patterns and structures. These simulations show how galaxies form along the filaments like pearls on a string. The strands of this web, the filaments, are where we find most of the universe's stuff. These filaments are dense regions where galaxies cluster together, drawn by the force of gravity. They are the highways of the universe, channels through which matter flows and accumulates. Galaxies cluster along these filaments, drawn together by gravity. These clusters are the bustling cities of the cosmos where stars are born, live out their lives, and eventually die. The interactions between galaxies in these clusters can lead to spectacular events such as galaxy mergers and the formation of new stars. But the filaments are only half the story. Between these dense regions lie vast empty spaces known as voids. These voids are like the deserts of the universe, where matter is sparse and galaxies are few and far between. In between them lie the voids. These are vast, expansive regions where galaxies are few and far between. The voids are the dark, empty spaces that contrast with the bright, bustling filaments. They are the silent, empty halls of the cosmic mansion. These are vast, expansive regions where galaxies are few and far between. In these voids, the density of matter is extremely low, and the few galaxies that do exist are isolated and lonely. These regions are the quiet backwaters of the universe, far removed from the bustling activity of the filaments. Imagine flying through space, away from the bright lights of galactic clusters. As you move away from the filaments, the number of galaxies begins to dwindle. The bright lights of the clusters fade, and you find yourself in a region of darkness, with only a scattering of faint, distant galaxies. You'd enter a region of darkness, with only a scattering of faint, distant galaxies. These regions are the cosmic voids, the empty spaces that make up a significant portion of the universe. They are the dark, quiet corners of the cosmos, where the light of galaxies is dim and distant. This is a cosmic void. It's a place where the density of matter is extremely low, and the few galaxies that do exist are spread out over vast distances. These voids are the empty spaces between the filaments, the dark gaps in the cosmic web. The relationship between filaments and voids is a delicate dance of gravity and expansion. Gravity pulls matter together, forming the dense filaments, while the expansion of the universe pushes everything apart, creating and enlarging the voids. This interplay of forces shapes the large-scale structure of the universe. Gravity pulls matter together, forming the filaments, while the expansion of the universe pushes everything apart, creating and enlarging the voids. This dynamic balance between gravity and expansion is what gives the universe its structure, its form, and its beauty. This interplay has shaped the universe we see today. The cosmic web, with its filaments and voids, is a testament to the forces that have sculpted the cosmos over billions of years. It's a grand, intricate tapestry, a masterpiece of cosmic design that continues to evolve and change. To understand how voids formed, we need to rewind the cosmic clock. Go back to the Big Bang, the moment of creation. In those first fleeting moments, the universe was a hot, dense soup of energy and matter. Tiny fluctuations, quantum ripples in the fabric of spacetime itself, existed within this primordial soup. As the universe expanded and cooled, these tiny fluctuations began to grow. Regions with slightly more matter attracted more matter, thanks to gravity's relentless pull. These overdense regions became the seeds of galaxies and galaxy clusters. The underdense regions, those with slightly less matter, became the seeds of cosmic voids. The expansion of the universe amplified these initial differences. Over billions of years, the overdense regions collapsed to form stars and galaxies, while the underdense regions stretched and expanded, becoming the vast cosmic voids we observe today. Not all voids are created equal. In the vast expanse of the cosmos, voids come in a variety of sizes and characteristics, each playing a unique role in the grand tapestry of the universe. Just like galaxies come in different shapes and sizes, so do cosmic voids. These empty regions of space devoid of galaxies and matter are as diverse as the stars themselves. Astronomers categorize voids based on their size and structure. This classification helps us understand the distribution of matter and the forces at play in the universe. At the top of the hierarchy are supervoids. These colossal voids are the giants of the cosmic landscape, stretching across unimaginable distances. These behemoths can stretch for hundreds of millions of light-years, dwarfing even the largest galaxy clusters. Their sheer size makes them some of the most fascinating structures in the universe. One famous example is the Eridanus supervoid, a colossal void located about 3 billion light-years away. This supervoid has intrigued astronomers since its discovery. This behemoth spans an estimated 500 million light-years, making it one of the largest structures ever discovered in the universe. Its vast emptiness provides a stark contrast to the densely packed regions of space. Then we have intermediate voids, smaller than supervoids but still vast, stretching for tens of millions of light-years. These voids are more common and offer valuable insights into the cosmic web. And finally, at the bottom of the scale, we have mini-voids. These smaller voids, while less impressive in size, are still significant in their own right. These relatively small voids, on cosmic scales at least, are only a few million light-years across. Despite their size, they play a crucial role in the structure and evolution of the universe. Each type of void offers unique insights into the universe's structure and evolution. By studying these voids, astronomers can learn about the distribution of dark matter and the forces that shape the cosmos. Supervoids, with their immense size and influence, provide clues about the early universe and the forces that shaped it. They help us understand the large-scale structure of the cosmos and the role of dark energy. Intermediate voids, more common than their larger counterparts, help us understand the distribution of matter on cosmic scales. They reveal the intricate patterns of the cosmic web and the interactions between galaxies and dark matter. And mini-voids, the most numerous of all, offer a glimpse into the ongoing process of structure formation in the universe. These small voids help us understand the finer details of cosmic evolution and the role of dark matter in shaping the universe. By studying voids of all sizes, astronomers can piece together the history of the universe, from the Big Bang to the present day. Each void, whether super, intermediate or mini, adds a piece to the cosmic puzzle. The study of cosmic voids is a testament to the ingenuity and curiosity of astronomers. As we continue to explore these vast empty spaces, we uncover more about the universe and our place within it. From supervoids to mini-voids, each type of void tells a story of the universe's past, present, and future. These cosmic voids, though empty, are filled with secrets waiting to be discovered.